In this video, I will solve a 4-player coalitional extensive form game by applying the recursive backward induction algorithm. A coalitional extensive form game is an extensive form game with an addition of coalitional utility function for each feasible coalition. In this talk, I assume that every coalition is feasible and that rational coalitions aim to maximize the minimum utility of their members. In general, coalitions may have any type of utility function as long as they are von Neumann-Morgenstern utilities. Okay, so coalition forming is defined as follows. If some players I and J decide to form a coalition C, so if C is equal to I and J, then they each become an agent of this coalitional player C. So I and J becomes an agent of coalitional player C. So their choices are guided by the utility function of player C, which is given by UC. Okay. Obviously, this is true only if they choose to form a coalition. In general, they are free to do so. But in the recursive backward induction solution, individual players join a coalition only if they have strict incentives to do so. Okay, now let's move on to the example. As I have just mentioned, coalitional utility function UC over here is defined as the minimum of UI, where I is a member of coalition C. Okay, so here's a 4-player game in coalitional extensive form game. Okay, so here is a 4-player coalitional extensive form game. In this context, it means that players can cooperate on top of being able to choose non-cooperatively. And I will illustrate the recursive backward induction algorithm on this game in 4 steps. Step A shows the standard subgame perfect equilibrium solution when every player chooses non-cooperatively. Okay, so and the solution leads to the outcome 30, 40, 30, and 0. Given the subgame perfect equilibrium, step B shows that both player 2 and player 3 in this subgame over here can benefit from cooperating by choosing F, as a result receiving a payoff of 60 and 40 for player 3, in which case both of them are better off. Okay, so let me just show you this payoff. So player 2 is better off here compared to the backward induction outcome over there, and player 3 is also better off here. The notation 2, 3 signifies the cooperation between player 2 and player 3. Okay. Anticipating this collusion, player 1 would then choose M2, which leads to the outcome 20, 0, 0, 100. Okay, and this is the solution in step B. Now let's move on to step C. Step C shows that both player 1 and player 2 cooperate by best responding to the solution in step B. So let's focus over here notice that if player 1 and player 2 cooperates, player 1 chooses M1, player 2 chooses A, then both player 1 and player 2 become strictly better off compared to the solution in step B. So let me just point out these two payoffs, and therefore player 1 and player 2, as shown over here, they have strict incentives to form a coalition and best respond with the choices given there. So the solution in step C is then M player 1 to cooperate and choose M1 and A, which leads to the outcome 30, 40, 30, and 0. Okay. However, moving on to step D, notice that player 1 can anticipate this possible cooperation between player 1 and 2. Player 4 anticipates this cooperation and would actually offer player 1 to cooperate. If player 1 chooses M2, player 4 can then choose A, which leads to the outcome 60, 0, 0, 60, which is better for both player 1 and player 4, right? And notice that the outcome over here was disastrous for player 4. That's why player 4 now has incentives to offer player 1 to form a coalition. In that case, let me also signify here the mutually beneficial outcome for player 1 and player 4 is 60, 0, 0, 60. And that is the solution of step D and also solution of the whole game, because there is no longer any coalition or non-cooperative play that players can improve upon. Okay, so this is called then the recursive backward induction solution, in which player 1 and 4 cooperate, and in the off path, player 2 and 3 cooperate, as I have explained in step A, and this is the final solution. Okay, notice that the only reason player 4 colludes with player 1 in the last step is the credible threat of cooperation between player 1 and player 2 in step C. That was a credible threat to player 4. And it leads to a very bad outcome, as I mentioned, for player 4. To make a point, let's assume that everything else being equal, suppose that the outcome 20, 0, 0, 50 is replaced by the outcome 35, 0, 0, 85. Okay? So that's an off-path outcome, obviously, and we made this change. Then player 1 would actually immediately choose M2 in the beginning of the game, okay? Would immediately choose M2 in the beginning of the game, non-cooperatively, and then player 4 would choose F, and that would be the outcome of the game. In this case, and notice that player 4 would not be willing to cooperate with player 1 because player 1 in the first place does not have any incentives to cooperate with player 2. And the reason is that here player 1 receives 30, whereas over there player 1 receives 35. So the coalition between player 1 and 2, which is shown in step C, would not be credible anymore. Therefore, player 4 is not willing to cooperate. Okay, the final outcome would be this. Okay, this example shows that off-path coalitional credible threads play a critical role in determining the recursive backward induction solution. Okay, let me raise over here, which the solution is illustrated over there.